That was well and efficiently done. I would like to add a couple of remarks before moving on, because as I said, both of these awards are very significant to me personally. I worked with Gene Tatini in a number of different capacities over the years, most recently when he was Deputy Director of JPL and I was making my fourth pass through NASA, still trying to get it right. And Gene was just an absolute gem in that role. As all of you know, we have a much recognized, very brilliant, very personable director of JPL in Dr. Charles Elachi, who actually was quite prominent in this event last year up in Pasadena. But Charles is not going to be the guy who makes the lab run well and smoothly and efficiently from day to day, and would be the first to tell you that. That role fell to Gene, and JPL is one of the nation's crown jewels in the space business. I am a proud alumnus of the laboratory, and for the last 12 years, Gene Tatini is the guy who has made sure that crown jewel stays well polished. So Gene, I'm just personally delighted to see that award. L-Cross, interest in the moon is on the rise, as I have long believed it should be. L-Cross was a brilliantly conceived mission, a very low-cost approach to making a determination concerning the water resources on the moon that will be available for future developers of a lunar base or lunar bases. As I say, brilliantly conceived, tremendously innovative, brilliantly executed, a very low-cost, very efficient, very clever mission. As someone who, not quite 3 decades ago, received the AIAA's Space Systems Award for a classified mission, I'm just personally thrilled to see the tradition of that award being conferred on the L-Cross team. And I won't actually say that I wish the intended recipient were here, because I really want him to be working on LADI, but it is a pleasure to recognize that team. Having just talked about our former Deputy Director at JPL, I now wish to introduce our new Deputy Director at JPL, also a retired Air Force 3-star. Larry's last position, and that's General Larry James, as I think most of you know. Larry's last position was as the Air Force's Senior Intelligence Officer. He was responsible to the Secretary of the Air Force and the Chief of Staff for policy formulation, planning, oversight, evaluation, leadership of Air Force intelligence, surveillance, and reconnaissance. So as an intelligence professional, I think it is literally true that you can find out more about Larry by Googling him than he would ever want you to know. And I won't sit here and read his bio, but I will point out that he is fully qualified, not just from the point of view of long experience in the corporate Air Force, rising to the rank of Lieutenant General, but fully qualified to be JPL Deputy Director with being a distinguished graduate of the Air Force Academy and possessing a master's degree from MIT. So when Larry left the Air Force, he wasn't leaving the space profession, and he wasn't even leaving us. He's now the Deputy Director and will be a very effective and much valued Deputy Director at JPL. I've worked also with Larry in a number of roles, and I'm really pleased to see him doing this. Larry, of course, is going to be moderating the panel that you are here for this morning, a conversation with space executives. I'm a space executive, but this conversation is not with me, so I think it's time for me to get off the stage and let Larry bring his panel up. General James. floor is yours, sir.
Well, Mike, thank you for that introduction, and Mike and Sandy as well. Thank you for just allowing me to be a part of this plenary session this morning and to kick off a wonderful AIAA conference here in San Diego. As you heard Mike say, this is a conversation with space executives. We were all sitting there kind of scratching our head and said, how do we end up being space executives, you know? We started off on the ops floor, the test floor, or whatever, so many years ago, and suddenly we ended up here on this panel, and what a great thing. And as you look at the title of this and you look at what we're supposed to be talking about, the first words in the little blurb is, the space landscape is changing. And boy, there's a lot wrapped up in that. And we have brought together what I consider to be a really tremendous team of panelists to talk about that particular issue, challenge, opportunity that we're all going to be facing as we look ahead. And I would just like to briefly introduce each of our panel members before we actually get started into the meat of the presentations and the Q&A. First up, alphabetically I might add, is Roger Crone, who is the President of Network and Space Systems at the Boeing Company. He's been there several years, and he really is responsible for 4 operating divisions focusing on space exploration, cybersecurity, missile defense, satellite development, and intelligence networking. A broad array of really all the areas that are important to each of us in this audience, I think, today. So we're really looking forward to what Roger has to say. Next up will be Mark Valerio, who's Vice President and General Manager of Military Space for Lockheed Martin Space Systems, and again, responsible for many of the critical military space programs that our military forces rely on throughout the world. Things like AEHF, DMSP, GPS, MUOS, SBIRS, and multiple other programs that are absolutely key to the efficient operations of our military forces. And then finally, Gabe Watson. As Mark said, he was surprised that he wasn't at the end of the line with the last name starting with V, but we had Gabe on the panel, last name starting with W. Gabe just recently moved to be the Vice President of GeoIT, Sensing and Science for Space Systems at Northrop Grumman in One Space Park up in Redondo Beach. And there he's responsible for really looking at advanced, innovative, and affordable space sensors. And obviously this is especially critical either as we look at the Earth or as we look out to the outer planets, whatever the case may be. Sensing is absolutely key to how we do business in terms of operating from space. So to each of you, thank you for being a part of the panel today. I just had some brief opening remarks to set the stage, and certainly as we go through the presentations, I would encourage each of you to either be thinking of questions you can ask verbally or writing down your questions, and we'll make sure that I give all the hard ones to the panel members. First, let me ask a question. How many of you know what your budget's going to be next year? Raise your hand. And I think just the things that are going on back in Washington kind of set the stage in terms of, you know, the comment that the space landscape is changing. If you look at the civil side, if you look at the military side, if you look at the commercial side, there's new entrants out there, there's people with great ideas, there's things like Inspiration Mars, there's SpaceX, there's a whole host of, you know, hosted payloads, disaggregated satellite systems, CubeSats, small sats, all of those things are in the landscape right now that frankly 10 years ago we weren't necessarily thinking about. And certainly in an era of reduced budgets, we're going to have to sort out how we as a community work through all of that, how we in business think about that. And I just wanted to briefly highlight a couple of things from a JPL perspective, really focusing on ingenuity, collaboration, and diversification. And I'll just talk ingenuity real quick right up front. So you see the Mars lander there, Curiosity on the view graph, and ingenuity. How many of you would ever thought of using the sky crane concept to land that thing on Mars? You know, it's just a pretty amazing concept. When I talked to the chief engineer at JPL, she said, you know, when they first came to me with this idea, she said, you guys are crazy. And yet, the more you dig through it, the more you work through the engineering and the mechanics and how you actually get a heavy payload on Mars, this turned out to be the best way to do it. And yet, who would have thought of that 5 years ago, that we could have even conceived of that or made it happen? So ingenuity, I think, is going to play an extremely important part in how we move forward, and certainly it's great for me to be a part of JPL and see the ingenuity that happens there every day. And then if you think about diversification, I just want to run a quick video, so if the folks there could do that. If you can go ahead and advance and start the video. This is just a quick look at JPL and all the missions that they've been involved in 2012.
Astronomers report the discovery of an Earth-like planet about 600 light years away from here. It is called Kepler 22b, and they believe it has a temperate climate in the 70s all the time.
Wide Field Infrared Survey Explorer. The images are breathtaking, proving once again Earth is a teeny tiny part of the universe when compared to everything else that's out there.
Scientists using NASA's Spitzer Space Telescope have discovered what appears to be an alien planet just 2/3 the size of the Earth. A heat-blasted world perhaps covered in molten lava.
And Pegasus is away, standing by for ignition. And we have stage 1 ignition. Ignition of the Pegasus rocket with New Star for an understanding of the ultimate destinies of our stars and galaxies.
And we have big news from out of this world tonight, specifically from one of Saturn's moons. A spacecraft operated by NASA's Jet Propulsion Lab has just confirmed that the basic building blocks for life exist.
Tonight, there is new information that reveals just how fast the world's ice sheets are melting.
Polar ice sheets in Greenland are melting at 5 times the pace of just a few years ago.
NASA's Mars Reconnaissance Orbiter spacecraft captured a photo of a gigantic dust devil racing across the surface of Mars.
From that image, we can reconstruct what this would look like if we were able to get an oblique view, as if we were in a helicopter flying around the dust devil.
We knew there were black holes, but so many? WISE found millions. Even in this tiny patch of sky, there are dozens. The infrared cameras captured the extreme variety, too, supermassive black holes known as quasars.
This is the first time a spacecraft has orbited an object in the main asteroid belt, and I want to congratulate everybody on the team on an outstanding job. This is a really unique accomplishment. Congratulations, everybody.
Thanks to ebb and flow, we now know a lot more about our celestial little brother, including that its crust is much thinner than scientists assumed.
This video was made by Ebb as it flew above the surface of the moon that we don't see from Earth.
Ebb and flow will be given one final instruction: to aim themselves directly toward the lunar surface and fire their thrusters.
The American Space Agency says it will send a new vehicle based on its Curiosity robot, which landed on Mars in August and has sent back detailed images of the landscape there.
Voyager 1 is now 120 times as far from the Sun as the Earth is. That means it's 11 billion miles out. They're very near the edge of the bubble the Sun creates around itself, called the heliosphere. We're getting very close to the boundary.
We should have parachute deploy around Mach 1.7. The parachute is deployed. We are decelerating. Vigil has separated where we found the ground. Standing by for backshell separation. We are in powered flight. We're at an altitude of 1 kilometer descending. Standing by for sky crane. Sky crane is started. Touchdown confirmed. We're seeing
Now, how many of you want my job? Tell you, if that doesn't get you excited about being in the space business, I don't know what will. Just to see the amazing panoply of things that this community can do. And that's not just JPL, that's the entire community. And that's really what I wanted to talk about briefly this morning, is the diversification that we have to think about, and then the collaboration we have to think about. Obviously, we all know the kind of the 3 components of space, if you will: civil, commercial, and military. And most people think of JPL as focusing on those planetary missions, deep space, Saturn, Voyager going beyond the solar system, those sorts of things. And yet, if you look at our business base, it's really quite diversified. Next slide. I left the clicker, so somebody needs to click the slide for me. Okay, there we go. So you can see there in terms of NASA, a fair amount to science, keep going, 35%, a fair amount to human exploration, about 60%, and then aeronautics, 5%. And then going on to the final slide that I just wanted to talk about. Go ahead, next. In terms of JPL, again, as I said, most folks think about JPL as that deep space, go to Mars, go to Jupiter, go to Saturn. And yet, if you look at how our budget gets allocated, the largest component of our budget right now is Earth science. And a lot of people don't think about JPL in terms of Earth science. And yet, as we've gone through the years, as we've looked at going beyond what we call the flagship programs like Galileo or like a Cassini, going to the Discovery missions, which are smaller missions and have to be competed, we have thought about ways of how do we diversify at JPL to maintain our business base, to continue doing great science for the community, and yet being forward-thinking in terms of seizing the opportunities that are out there. And then finally, just the collaboration piece. If you look at that video of the Mars landing of Curiosity, that really wasn't about JPL per se. Yes, JPL brought it all together, they built it, they did tremendous work, but look at the amount of collaboration that went on there. 9 NASA centers, 13 countries, 72 universities, and 3,000 vendors. So putting together a team like that, I think, is going to be part and parcel of how this community has to do business in the future. The science teams, the commercial teams, the other countries that are interested in partnering with us. How do we bring all that together in a very challenging budget environment here in the United States to move forward with our science and our commercial and our DoD capabilities? I think those are the challenges that are going to face us as we look to the future, and really not having to do it all ourselves from an organizational perspective, but looking ahead and how do we do that collaboratively across this large universe of space partners that may be out there. So with that, I will stop talking, and then I will turn it over to Roger for his views on how we move forward in this very challenging environment. Roger?
Okay, there we go. All right, great. If I can have our first slide, please. All right, hey, thanks a lot. 5-hour flight from Dulles to San Diego last night. I think half of you were probably on it with me. A great time to kind of reflect on what's going on the 2 different coasts. My business at Boeing, I'm responsible for the space portfolio, which is frankly maybe the more fun business. I've also got a lot of Boeing's portfolio that is in DoD, some of the 3-digit agencies, and some of the civil agencies. And I have spent probably the last 3 or 4 months, and probably will spend the rest of the year, trying to understand what my long-range business plan looks like for 14 and 15 and beyond. I've been in the industry since 1977 when I graduated from college. The conversations we're having at Boeing is this is the 4th downturn or the 4th roll through the cyclic nature of the defense industry. Reflecting on the way out, I thought, you know, that is certainly true in DoD, but if I think about my career and the work that I've done in space, if we look at, for instance, the NASA budget, and I've got some numbers here, at the time of JFK's speech in 1961, the NASA budget was about 1% of the federal budget. And it increased quite significantly so that in 1966, the NASA budget was 4.5% of the federal budget, which, by the way, is by far and away the high water mark. Since that time in 1966, we have been on a long-term decline, not a cyclical behavior. When we landed on the moon for the first time in 1969, the NASA budget had fallen to 2.5% of the federal budget. When we last landed on the moon in 1972, the budget had declined to 1.5%. And today, at the $7.7 billion mark, we are less than 0.5% of the federal budget. And some of the discussions that we had on the airplane on the way out, and I hope this isn't true, but there is a rumor that some plans are being drawn for a 14 budget that's compliant with sequestration, which may be as low as $16.1 billion. If our friends from the Air Force were here, if they had been allowed to attend, they would have somewhat of a similar story. The budget for Air Force Space, which actually behaves relatively differently than the budget for aircraft in the Air Force, is also not necessarily on a cyclical trend, but on a relatively long-term decline. So at Boeing, and having done this for about 40 years, I think a lot about that. If that is the case, and I submit that it is, what has happened to us in the industry and what is likely to happen in the future? And if I could make one point in my opening remarks, it would be that what we have seen is frankly not a long-term decline in the activity that we all participate in, but frankly a shift. A shift from what was primarily a military government funding and NASA funding to civil and commercial. Larry showed a great chart that showed the three major funders of space: military, civil, and commercial. And I think what we have seen and will continue to see is the dollars from the military part of your Venn diagram go down, and the dollars in civil and commercial go up. And with that, I'd like to make just a couple quick remarks and then take some of your questions. If we can go to the first chart, please. When I think about space, and I think about this a lot, there maybe in three categories, things that we can do and can do well in space. We communicate, we can observe the Earth, we can observe things in space, we can observe other heavenly bodies, and we explore. You know, the whole world of communicating in space really started with Sputnik, which was obviously a government program, but if you look at the numbers, any way you want to measure them relative to communications in space, it is now dominated by commercial. And at Boeing, we've even taken our Air Force work and flipped it over to firm fixed price commercial type contracts. And we see that continuing. We don't see that abating. We see, frankly, most of the innovation in communication in space really now coming from the commercial side. And we are now passing R&D and satellite bus design from work that we have done for the commercial satellite providers and providing that, frankly, at no development cost to our government and military customers. To observe in space obviously started with some very large national programs, but we've seen the birth of a lot of entrepreneurs and commercial ventures, you know, GOI, Digital Globe, a lot of people now in hyperspectral and multispectral observations. I got a briefing the other day that said John Deere is now designing tractors that will be connected to satellites and will be able to moderate the amount of fertilizer and seed that they put on farmers' fields based upon input that they get from space observations. And I think we're finally seeing the, if you will, observed part of our industry coming of age from a commercial standpoint. And then maybe the most exciting, and the one that we may talk about the most this morning, is what's going on in space exploration. You know, really started as a anchor R&D by NASA and other government agencies, but now the talk, you know, if you will, the new space talk is all about the commercial entrance. And I would simply point out that doesn't mean necessarily it has to be small entrepreneurial startups in garages. You know, companies as big as Boeing, Lockheed, and Northrop can also play in commercial space exploration, whether it be through our CST-100 or, frankly, by selling rides on some of our commercial EELVs. But I think the trend in all three areas is unstoppable, and that's going to be a transfer of funding from government agencies to those that are more civil and commercial. Next chart, please. Now, to enable this, I think we need to do three things. The first on the left is Boeing 702 SP, which is our all-electric satellite, just in case you haven't seen any of the 5,000 ads we've taken out. And what we did there is we believe we innovated in, frankly, the way we designed the bus, and went to all-electric Zips drive, and that allowed us to double manifest on a Falcon 9. So, okay, now think about that for a second. Okay, here's the guy from Boeing, right, talking about how he's going to redesign his satellite so he can dual manifest on a SpaceX rocket. Okay, I think that's a marriage of, if you will, new space and more traditional space. In the middle are some research projects, and really what that's meant to mean is that we have to design smarter, but in the middle we have to collaborate better. One company can no longer afford to do enough R&D to cover the waterfront of everything that can be done in space. And so what we're seeing is collaboration amongst, if you will, the billions of R&D that's being done across the industry. Some companies are specializing, some are focused on life sciences, some are focused on bus, some are focused on payloads, and some are focused on launch. And for us to make up the funding gap that will be created as the government budgets shrink, we all have to be more thoughtful and, in a way, self-rationalize where we spend our R&D. And what you'll find is Boeing, Lockheed, and Northrop, we're not spending our R&D all to design new traveling wave tubes. Is that we have, through, if you will, the laws of the marketplace, started to do a little bit of specialization and, frankly, to collaborate and share buses and payloads to the benefit of our customers. Then that third kind of funny-looking thing is a business structure for a joint venture. I would say the third part of working smarter is to access new sources of capital. Used to be we would wait around for the next TSAT, the next cost-type development program. We would expect the Air Force to come in with cost-based development dollars. That's not likely to happen. I don't think we'll ever see another program the size of TSAT coming out of the Air Force. And what it means is we need to find new business structures that support new business cases and access new sources of global capital. And that means we'll have to talk to ourselves, to private equity, to the debt markets, to find sources to actually develop business cases and business structures that support the design, the building, and launching of satellites. Okay, my last slide real quick, if you could please. This is Kavya. She is a millennial. She is one of the thousands of people who are going to replace us. There's one of the thousands of people who get up every day and still want to participate in the industry. Kavya is there working our water drop test on the CST-100, part of our commercial crew program. Kavya still wants to be an astronaut. Kavya is still excited and passionate about what we do and those things that we can accomplish by harnessing space and space travel for the good of us all. And in her, we all get excited and motivated. It reminds us why we are here and why we come to work, and all of the things that we have yet to do and problems that we have yet to solve in space. Again, in summary, what I would say is what we're facing now from a budget standpoint is probably not cyclical. It is a long-term decline and therefore a shift of collaboration, innovation, research dollars from what used to be primarily government and DoD to multi-agency, multi-source funding. And its agencies, the non-government agencies, AIAA, the FFRDCs, the national labs, and industry collaborating together that will keep our industry fun, exciting, and healthy. And I look forward to your questions. Thank you.
Thank you, Roger. Mark, you're next.
Thank you. All right, can you hear me? All right. Thank you, General James. So the panel topic was, in critical times, what roles do collaboration and ingenuity play in enabling mission success? And I want to spend a little time talking about that, and what we're doing at Lockheed Martin Space Systems Company, internally and externally across the mission areas we talked about. But first, let me show a real quick film that really explains it pretty succinctly. Hopefully. Yeah, if you could play that video, please.
We live in a remarkable world, beautiful and often mysterious, demanding and sometimes dangerous. To thrive on this planet means continually evolving our capability to understand and manage interactions in a dynamic and highly complex environment. To seek, develop, and field methods to improve our global security. To deliver more effective ways to interconnect and to move critical information. To create systems that enable a better understanding of nature's processes and our influences on them. To build global resources that drive economic growth and enhance our way of life. To imagine and design new architecture that allows us to explore our universe and measure and understand our world in ways that would otherwise be impossible. At Lockheed Martin Space Systems, this is what we do. The missions we support are at the heart of the human drive to better understand and manage our interactions in our world and those beyond. Meeting this challenge demands in-depth, end-to-end mission knowledge. It means partnering with the best minds in the industry to analyze and understand the primary drivers of next-generation mission requirements and bringing forward new ideas for critical mission architectures. It requires leveraging innovations that deliver greater capability at lower cost and at lower risk, developing and nurturing new enabling technologies, applying innovative engineering design approaches, and constantly streamlining processes to deliver solutions faster and more affordably. Together with our mission partners, we are committed to developing solutions that secure, enhance, and explore this remarkable world we live in. A world that stretches from the depths of the ocean to the farthest reaches of our universe. This is our mission. Lockheed Martin Space Systems. We deliver mission solutions.
So let me talk a little more depth about the things that we're doing to collaborate and to bring innovation and ingenuity. Space Systems Company is really made up of a number of business areas and lines of business, as you see: strategic missile defense, civil, military, special programs, commercial ventures, and advanced technologies. They really are customer focused. We reorganized last year to drive them to collapse the numbers of programs and to really be customer focused. But we're supported by a functional organization of engineering, production, subcontract management that provides people, process, tools to all these programs, really to improve communication, lessons learned, best practices, and drive commonality across all these mission areas and all these customers. If you can go to the next chart. And so some of the things we're really trying to do is drive commonality of components across the various mission areas. And you can see some of the things we're doing here. We have a couple of buses. Really, one of the first systems that we have that drives a lot of this is our A2100 commercial communication satellite, as well as some of our imaging satellite, which is classified as an LMX bus. There are common components for these things and common software reuse to drive down the costs. We are, reusing things over and over again from one mission area to another. We go to the next chart. So I'll just give you one example, and this is using the commercial industry. Some of our heritage companies, we have launched over 100 satellites, quite a long time in orbit, and we've gone through about 7 different series of satellites before we evolved to an A2100 class, first launched in 1996. That has won the Frost Sullivan Award twice as Product of the Year. That satellite was then evolved to be used as the foundation for advanced DHF, MUOS, now GPS-3, and GOES-R. And as so common components, reusing those for these systems really drive down the costs, allow us to get economies of scale in buying products and doing a better job of resource allocation of folks. But this was done before we actually moved into a functional organization. So we were stovepiped at the time. Let me show, and so there's a lot more really to be done. Let me show you where we're going. Next. So if you look at where is the Air Force gone in the future for some of the national security space, they're really driving it. You may have heard it from General Shelton at the last National Space Symposium, really is trying to find that nexus of affordability, resilience, and capability. And we fully support that and are really driving to do that with some, I think, very innovative approaches. Things like using model-based engineering and additive manufacturing, new manufacturing techniques that we're going to revolutionize the way that we do business. Driving down costs by really driving a commonality. Roger showed a dual launch. One of the ways to significantly save money is to be dual launching, essentially aggregating on a launch. And in the upper right, you see a GPS-3 launched. A dual launch either on an Atlas or on a SpaceX system. You see some of the other things that we're doing, and working in collaboration. You look at MUOS, for example. MUOS is the next generation UHF satellite, and frankly, Boeing reused their components that they have, and that's the legacy payload on MUOS. If you look at advanced CHF, collaborating with Northrop Grumman, they provide the payload. They're reusing that payload for other communication systems. So there's a lot of reuse going on. So go ahead, let's go to the next chart. I'm going to talk really a little bit more about the model-based engineering on the next chart. Don't go there yet, but one thing that's really exciting is this additive manufacturing. And some of the things that you can do with additive manufacturing are printing of components and building of things that have never, you could have never imagined before. I have a little thing here, you can't see it, but it's a ball made out of titanium powder. So instead of having billets and forgings, you have a small flask of powder that you actually print components. And we're flying printed components now, and the Maving satellite will fly another one. Gene, if you could stand up, let me pass this around. I'm going to throw it at you. Pass that around. You cannot, it is unbelievably tough. You cannot break it. So what the imagination and ingenuity is doing with bringing technology forward is absolutely unbelievable. We will one day print a satellite. And I'll talk a little bit more about the additive, the model-based engineering, but with A2100, we are investing significant amount of money in refreshing that platform, the software, the processes, and it's not just about design. We have a propulsion system that we remove 50% of the welds. It's flexible to be electric propulsion, to be a hybrid, to be a liquid propulsion, with really just a quick change of some components, really simplifying that design. And we actually have put a satellite in geo orbit using all electric propulsion. We didn't plan that, but we certainly learned a lot from doing it. And also reducing components with a new inertial measurement unit that we are working in collaboration with Honeywell. So a lot of things left to be done as we really drive collaboration across all these systems, whether they be civil, commercial, or military. And it's really enabling quite a bit of cost reduction, allowing us to drive to that nexus of affordability, capability, and resilience that General Shelton talks about. Go to the next chart, please. So if you look at model-based engineering, some of the tools that exist today, really in improvements in the gaming industry as well as the movie industry have allowed us to fully utilize virtual prototyping. I actually, as an engineer, first used some virtual prototyping about 18 years ago, but it was really on one specific program and it wasn't very broad. The capability we have today in model-based engineering, not only is it factory simulation, so you can lay out the factory properly, but it is building the satellite virtually before you cut any metal. On GPS-3, we have fully utilized it, and in fact, in assembling that satellite, we have not had one mechanical interface issue because that has been completely ringed out in this virtual prototyping capability that you see there in the lower right. Not only does it help with the design, but it also helps with training of our technicians. They are actually, in the upper right is a technician that is actually building the satellite virtually. He's an avatar and he is building that satellite. So he has completely wrung out how to build the satellite, where do they have interface issues, where they have access issues, and so it's used for that, as well as it's in the manufacturing instructions. So the world of 2D drawings and the world of written work instructions is gone. We are bringing and all of us are doing this, bringing it forward to be able to simplify, reduce costs of building these systems that we have. Next chart. So as you see, a lot of things that we're doing to really drive collaboration, ingenuity, innovation. How important it is critical for us to remain the spacefaring nation, leading spacefaring nation that we are today. It is critical that we collaborate internally across missions, across programs, and it's not always what you buy. I think one of the most important things is how you buy. Having grown up in the commercial, fixed price world, it is such a difference between that and what you see in the military world. But things like work we've done with the Air Force on the Advanced CHF program, the SBIRS program, and GPS to reduce oversight, reduce governance, reduce paperwork, and in fact, we've saved over $1 billion on Advanced CHF vehicles 5 and 6. So we're continuing to work that with our military customers, as well as using what we've learned from the commercial sector. So, thank you.
Thanks, Mark. Gabe, over to you.
Thank you, General James. Well, I don't know about you, but every time I see videos like the one that JPL showed, the one that Mark has shown, the comments that Roger and Mark have made, it just reaffirms my gratitude for being part of this industry, and hopefully it has that for you as well. I'm speaking about innovation for affordability today. Like Roger and Mark, General James, I've been in this business for 30 years now. The space business at Northrop Grumman, primarily focused on satellite systems. So my comments today will be focused in that context. And it's really a pleasure to go at the end of the table here because I see tremendous commonality in our messages. And it gives me an opportunity to tailor what I'm going to say a little bit to emphasize a point or two that I was hopeful I'd have time for. We've heard about the budget environment. That's been well said. It's a difficult time. We're going to be called upon to preserve freedom, to advance discovery. How do we continue to do that in this environment? Well, we need to innovate for an affordable future. And that innovation takes a couple of forms. It takes the kind of form that we've been hearing about, during the design phases, design reuse, aggressive risk management, streamlining requirements, using cost as an independent variable, designing to cost, streamlining production, economy of scales. These are all very good things to do. And I'll touch on that a little bit. That's more of an evolutionary path. But where I want to spend some time today is to perhaps get you thinking about the use of aggressive engineering for space systems. And then I'll also end up with a couple of examples and then touch on collaboration. So next chart, please. So, someone mentioned 4 cycles. Well, we've been here before. We have increasing global threats every day in the news. Limited resources, uncertainty in multiple dimensions, but at the same time, this industry is called on to preserve our freedom, to help preserve our freedom, and to advance discovery. So we have a couple of choices. Do we evolve our systems today to get to a different point on the cost curve? Or do we apply aggressive engineering to innovate, to get to an entirely new cost curve? Ladies and gentlemen, I think we need to do both of them simultaneously. Let me give you some examples. Next chart, please. This is not new. Here's an enduring mission since the beginning of civilization: information delivery. It probably started with storytelling, perhaps some drawings, letters, magazines, books, libraries, radio, television. And over the span of time here, it's been important to have information delivered timely and for it to be accurate. Many of us grew up watching that man in the upper left corner every day. And then many of us grew up in the middle of nowhere. That's my case. And so a local newspaper, daily, fairly static, and then moving with, in the same medium, to hourly, CNN, national newspaper, daily. But look at the far right. Look at the transformation that we have today. But notice the application of advanced technology, not related to the information, but in terms of internet access and on your smartphone. Look at how this information delivery has been transformed to daily, hourly, to instantaneous. And it's instantaneous anywhere you have connectivity. How did that happen? I submit to you that's through aggressive engineering to innovate. We had invention, improvement, transformation. How do we do that for the space business? Next chart, please. This is another situation in image capture. Probably started with portraits, and then plates, and then film. I remember as a kid going to drop off the film so that we would receive the pictures back in several days. What a great time to open the package, but then you had to wait to see the quality of the film. So the investments were made to increase the cycle time so you could have 1 hour delivery, but still the quality was part of your surprise. Today, with digital technology, you all have these cameras with solid-state memory. You have instant access to photographs, to images. And not only that, you can send them instantaneously. You can measure quality. You can archive them. You can edit them. How was this transformed from days to hours to seconds? Do you see the application of aggressive engineering? We need to do that for space. Next chart, please. Mike, I couldn't have described L-Cross better. L-Cross was an amazing achievement. I was very pleased to see the NASA Ames team acknowledged today. But this is an example of not moving down an existing cost curve. This was getting to a new cost curve. And that's what we need to do. We need to aggressively innovate as well as evolve our existing systems. Please make no mistake. We must preserve freedom through low-risk evolution of our programs of record in the space business. The nation, actually the free world, is counting on us to do that. But what I'm saying is, if you listen to the facts and figures that Roger quoted, we have to do something fundamentally different. So what we're encouraging is to follow suit with information delivery type transformation and image. How can we apply aggressive engineering to the space business? LCROSS is an example from 4 years ago. Let's look forward to the James Webb Space Telescope. Next chart, please. Now this is an amazing observatory. It's under construction as we speak. Forecast to be launched in 2018. It's going to operate at the second Lagrange point, 1 million miles from here. It will stare into deep space with cryogenically cooled infrared sensors. It'll look back to the beginning of starlight and the first galaxy formations. It's an amazing instrument. It has a warm side. It's about 85 degrees C. It has a cool side. It's minus 230 C. How's that accomplished? 5-layer sun shield the size of a tennis court. It has a 6.5 meter segmented optic. Tremendous achievement, all the science that's going to occur. We heard earlier in the JPL video about exoplanets. That's not in deep space. That's in our galaxy. That's in our neighborhood. I checked the Kepler website a few days ago. There's over 3,500 candidate exoplanets found by Kepler. Next chart, please. This is an out-of-date histogram of the ones that have been confirmed. Is there a way that we can leverage the nation's investment in Webb to further exoplanet exploration? I believe there is. We can apply the same type of deployment mechanisms, the same type of materials that are in the James Webb Space Telescope sun shield to create a star shade. Next chart, please. And so if we have a star that has some exoplanet candidates, we can fly in formation a star shade, a moving dark spot, as an occulter, so that we can directly image the exoplanets. And we can do that at a far different cost point, a completely different cost curve than if there was a separate mission. We have to do the linear evolution to improve affordability of our systems today. And we need to aggressively engineer for the future. Next chart. Next chart, please. So, this is a time when we need to maximize collaboration. I think everyone has said that. I'm just going to foot stomp that. And I will tell you this. I've said this before in public. I wasn't going to say it today. But I am so thankful that I'm an engineer and a scientist, and I'm living at this time. There's not a more exciting time. And I really like seeing the woman that is part of the astronaut program. We need to continue to work with middle schools and high schools and universities to keep this industry going. We need to collaborate with the national laboratories and the FFRDCs to make sure the right technologies are identified and matured. And then industry needs to tap into other investments, like Roger was saying, to mature those and to apply those. And then, as Mark was saying, to use those across a broad range of applications. And of course, our government and commercial partners, we're all in this together. Thank you very much for your attention. I look forward to your questions.
Again, thanks to the panel members. I think you can see that there's a lot of thinking going on out there about how we move forward into the future to take advantage of the opportunities that are being presented, but addressing the challenges that we're all going to face. The first question would be for Roger. You focused a fair amount on the commercialization of the SATCOM world and how that history has taken place over the last couple of decades. Putting your crystal ball in play, how do you see 20 years from now commercialization really being in play in terms of sensing, in terms of launch, in terms of tourism, for example, do you think that will drive all of space, not just SATCOM, from a commercialization perspective?
So how long is our panel? Well, I think it's inevitable. On sensing, there are obviously government and military reasons to do sensing. I think that is the base. I think what sensing is going to allow us to do is to unlock some mysteries and some value and economics in the planet that we've not been able to unlock before. I talked about what John Deere is doing relative to farming. If you talk to some of the large mining companies, they're looking at sensing from the same way. You get to the point, I showed a little GPS receiver on the sensing part. Two-way sensing, geolocation, smart tags. We can't even imagine if we can get the price of sensing down to where it is really ubiquitous and we can build it into our systems. You'll have a two-way GPS in your car, right? And you'll be able to track your car on the highway, and like Google Maps does today, you'll get traffic information through a GPS fusion cell that measures the speed of your car on the highway. And then we'll find an entrepreneur who knows how to make half a cent per signal on the GPS sensing and creates money with that. On launch, we spend a lot of time on launch. By the way, one of the great alternate structures, if you remember the chart, is United Launch Alliance. It was a way that, frankly, we were able to come together and attempt to get at some of the issues around cost and launch. And new innovative acquisition structures like the block buy is going to help us reduce the cost of the highly reliable EELV program for the United States and their national security payloads. However, on launch, we are subject to called the tyranny of the rocket equation, and there's some great literature that's been done on that. We can reduce the cost of materials, we can reduce the cost of labor, we can vertically integrate, we can use advanced manufacturing, but as long as we are working either LOX hydrogen or LOX kerosene, we are stuck with the tyranny of the rocket equation. And there are other ways. I mean, we're doing some things, reusable first stage. There's a program out of DARPA called ALASA to try to get, I think it's 100 pounds for $1 million into low Earth orbit. But I think that's going to only take us so far. I would tell you the first thing we probably need is a US-based LOX kerosene engine, so we can better understand our value stream and we have ownership of propulsion. But I think eventually it's going to require a different propulsion system to really crack the launch equation. And tourism, listen, I think I would be remiss to not absolutely say tourism is alive and well. Now, right now, you and I can't go, but Bezos and Tito and you can buy a seat. It happens to be really, really expensive. But Virgin Galactic and others are going to break into the space tourism business. And we do some work with Bob Bigelow. Bob is trying to eventually get an alternate location in low Earth orbit, which I would comment really isn't Motel 6. It's really to provide research access to those countries that are not a signatory to the ISS treaty and can't get an astronaut slot on ISS. But I see, we put that all under the category of tourism, which tends to connote not a serious venture. I'm the other way. I actually think traveling in space, going to the Bigelow Space Station is a serious venture, and I think we're all somewhat amazed at the resiliency and the depth of capital that's willing to go towards people who want to get 300 miles above the Earth and take a look back and see the curve of the horizon. So all three of those, I'm really, really optimistic. I think for companies like Boeing, it's, okay, where's the right place for us to play? And where is the cost, benefit, risk, return, and how do we get the business case to close? Thanks.
Good. Thanks, Roger. Next question for Mark. Everyone talked a fair amount about collaboration. I know Roger mentioned in the R&D space and how we do that, but the question is, how do you indeed collaborate, especially when businesses still want to maintain intellectual property rights? They must compete in this trade space against each other in certain instances. So how do you effectively do that collaboration across business entities as well as government labs and those sorts of things to bring this together efficiently? Any thoughts on that?
Yeah, sure. I just want to add a little bit on to Roger. From the commercial standpoint, that sort of is my love and where I came from. I've had a lot of debate, and you've heard a lot of people talk about leveraging commercial, and so when you hear that, you should ask, well, what do you mean by commercial? Because everybody has a different definition of what commercial is. Some people say, oh, I want to buy it fixed price. Some say I want to buy it off an assembly line. Webster's definition of commercial is buying a product or service from a non-government or a non-government entity buying a product or service. So that's what commercial is. I personally believe and agree with Roger that it's going to continue to expand, and if it happens in the movies, it's going to happen in real life eventually, and whether it be tourism or anything else. And you look at collaboration, I was with a company, RCA at the time, and we collaborated with Hughes, two of our legacy companies, and started a company called EOSat. And EOSat leveraged the Landsat imaging system to be able to go off and sell that image. Well, it just so happened that it wasn't a great business venture at the time, but we happened to be 20 years ahead of our time. And today it actually is. It transformed into space imaging, into other systems that are, selling that imagery, so that, I actually tried way back then, that's about 20, 30 years ago, to buy an image of my house, and it was something like $10,000 to actually do that.
That was free.
And today, you can do it for $20.
It's been transformed.
It's absolutely amazing. So I think commercial is really going to continue to expand. Back to your question on collaboration with various constraints that we have. We collaborate a lot. You may look at it as all competitors up here, but we call it competimates. Where we compete on one day, and the next day we are collaborating together. I mean, I mentioned MUOS and Advanced EHF. You can go to SBIRS. You can go to many of the commercial systems that we work together. ULA. We're always there's legal ways to make sure that each of the parties are protected where they need to be. I think one of the biggest moving points, I think the biggest places to leverage is collaboration amongst our customers. It is sometimes very difficult to drive to the innovation and reuse of components when everybody has different requirements. It is sometimes tough, and you have to point that out. For example, at SMC, they have different directorates, whether it be the SBIRS directorate, the GPS directorate, the COM directorate. Well, each of those areas have different requirements for parts. If you go look at comparing NASA to the Air Force, they have different requirements for soldering, right? It's different solder specs. So we have to train our technicians to be able to to do the NASA solder spec and do the SMC solder spec. And commercially, we don't have to worry about that at all, because at the end of the day, commercially, it's about a product that's delivering a service. And so, that's one of the biggest areas that I think more collaboration is really needed, is driving to more standards across, whether it be parts, specifications, even things like I talked about for, how we build hardware. So I think that's the biggest area to push. There's lots of collaboration happening right now. In sessions like this, we all take the opportunities, how we can work together better. So I think it happens every day.
Great. Okay, thank you, Mark. Gabe, the next one's for you. You talked about creating an entirely new cost curve, and I think this question relates very much to that, essentially asking, do you believe it is now time for the aerospace industry en masse to more forcefully push back on federal procurement requirements to enable more effective, efficient, and affordable solutions to national needs?
Oh my, General James. I'll take a crack at that one, but first I'd like to talk a little bit about sensors. I've been thinking a little bit about sensors lately in my new assignment. And hyperspectral sensors, our job is to manipulate the electromagnetic spectrum. And so as capabilities become more advanced, I see, as Roger stated, tremendous opportunities for hyperspectral sensors. It goes along with high-speed data processors and more efficient data communications to route the data. On collaboration, Mark and I are aware of a collaboration that Lockheed Martin and Northrop Grumman have on a protected SATCOM initiative for a low-cost terminal that, along with telecom systems. So, the collaboration is alive and well. I think that necessity is the mother of invention regarding collaboration and change in how we operate. I would be the last person, I believe, that would say that we should mount a concentrated effort to take on the FAR. But I will say that I believe if we are going to, and I'm getting back to my other points, if we're going to retain our leadership position in the world for preserving freedom, connecting people and communications, and advancing discovery, that I think everything has to be on the table. And thank you, General James, for letting me take some time to think about that answer.
Hey, Larry, I'll take on the FAR.
Sure.
So we're talking about innovation and ingenuity. Raise your hands, how many people have seen on one piece of paper the flow chart for the 5000.2 acquisition system? You cannot read the font. It is impossible. And we talk about commercial. There's no commercial entity, whether they be national or international, will buy anything like that. So if we want to talk about innovation, we ought to innovate on that. I mean, we really should, because it is unbelievable. I know of a program that almost $1 billion was spent before any metal was cut. And it's just, I would never think about that. I mean, do you buy a car that way? Do you buy your house that way? It's just sort of amazing to me. Coming from a commercial, working mostly of my career commercially, it's absolutely unbelievable.
Roger, you look like you want to say something.
Well, I think it's 3 for 3. Let's see. But I wouldn't necessarily throw it all out. So I think because we spend the taxpayers' money, we're in this kind of funny fishbowl, and there's accountability to the agencies and to Congress. I think what we've seen that works successful is tailoring of the FAR and the spec, and we see it both at NASA and at the Air Force. And I would tell you, I think collectively the community has made some great strides lately in fixed price production contracts, where we've been able, we use the word insight instead of oversight, where we provide the customer the insight that they need to make sure we're spending the dollars according to the contract, that we're good custodians of the taxpayers' money, and that they're getting a quality product. But we don't need more people observing the critical design review than went into creating the data for the critical design review. So I think, by the way, I think everybody realizes that we are sometimes a victim of the system in which we have grown up. And most of the customers that I talk to understand that, and they're working hard to find ways to streamline. We all have to work together. We need AIA, we need AIAA, all of the companies, big and small, to point out the cost and the fallacy of the procurement system we have today to get to one that allows innovation is more efficient. So,
very good. Thank you, Roger. This is for everyone. I would just ask for a short answer from each of you. We've heard a fair amount of discussion on disaggregation, kind of as a new way forward, less risk, more flexibility, et cetera. What are your thoughts on disaggregation in terms of space systems, and are you positioning your company to enter in that world? So we'll start with Roger.
Okay, it's another tool in the toolbox. Right? There have been a lot of studies. Paul Kaminsky did one. There have been several since. I think Tom Moorman did one. And disaggregation has lots of advantages. We are clearly working on that. We're spending more time on smaller buses and hosted payloads than we ever have. We see some huge advantages, some of which we can't really even address in this forum. On the other hand, it is not for every mission and not for every payload. James Webb, you could disaggregate James Webb, I guess. I'm trying to think about what you would do, what the numbers look like. You might get a larger optical distance, but it might be more expensive. On the other hand, there are other missions for which free flyers, flying in formation, actually create an advantage in sensing, an advantage in reliability and resiliency in the constellation. So like many pendulums, this is swinging more towards smaller payloads and disaggregation, but I would also say there are still missions for which an exquisite payload is the most efficient way to address the mission. And I would tell you it's just one of those things that we're adding to the fray, and for some missions we use it, for some we won't.
I agree 100%. Probably couldn't say it much better. There's a lot of things that it is really great for. Technology refresh rates, lower cost, higher quantities to be able to continue to drive the costs down. Although, as Roger said, I don't think it's for every single mission, because in some missions, physics dictate size of apertures, things like that. I personally think, having worked NASA programs for years, mainly with Goddard, they used to have a thing called missions of opportunity, and if there was a space on a satellite, they'd be putting a sensor on it. And I really strongly support the hosted payload, being able to, and if you have size, weight, and power on a satellite, and you're able to integrate a mission on that works in that orbit and has the correct downlink and everything else, why not? I mean, it's really beachfront real estate. I mean, we ought to be using it wherever we possibly can, and I applaud the Air Force with their solicitation they have out there on hosted payloads. I think we need to take a lot more advantage of that, and and disaggregation works in some cases. I think space situation awareness is a great place for that. We should be understanding what's in the neighborhood of our satellites, and we can do that pretty simply and very cost effectively today. So I think it has its place. I think it's got a lot of pros, some cons that you have to understand, and it's not a it's not a panacea for everything. But I've always said for the last couple of years is that we have to understand how it fits into the total system architecture, not just from a platform perspective.
Great. Thanks, Mark. Gabe, comments?
Roger, Mark, I could not have said it better. Another advantage of going last is I can say ditto. It's not for every mission. We have some customers that are creating multi-mission platforms. We have other customers that are looking for distributed and disaggregated architectures for survivability and resiliency. Hosted payloads. It's a great statement. It's another tool in our space systems toolbox, and Northrop Grumman, Lockheed Martin, and Boeing are aligned on that.
Okay, our final question, and Gabe, I'm going to start with you,
okay.
Since we'll go down that way. But Roger touched briefly on what we call the millennials, the young lady that was fully engaged there. So how do you see our outreach to that millennial generation in your company? Do you see that we are indeed growing a new generation of space fanatics? And what do we need to do differently, if anything? And just a brief answer as we wrap up.
Yeah, great question, General James. Let's see, I have a 13-year-old and a 26-year-old. And I will tell you that my 13-year-old knows everything about the next set of NASA missions. He talks to me about Webb all the time. He wants to know how many planets Kepler is discovered now. So, and that's all through STEM and open houses at your company or internships, math counts. I don't think we can do enough to touch that age bracket. Clearly, internships in high school and college, we need to do more of. We have been doing that. Interaction with universities, and professors and students. You know, we live in an incredibly exciting time, and it's with those types of videos that we saw today and interacting one-on-one, this is a very exciting place to be if you're an engineer and scientist. So I believe we're doing the right kinds of things. I think that we probably can't not do enough of it.
Okay, thanks, Gabe. Mark?
Yeah, I had the opportunity to be on a panel last year at AIAA and to talk about this very, very subject, and it's something I'm very, very passionate about. You know, and it comes down to a couple different areas. You know, advertisement, communication. You know, Roger talked about GPS for a little bit. You know, how many people really realize what GPS does for the civilization? I mean, I know folks, I go hunting a lot, and you know, they sit there and say, well, why the heck do I need a satellite? I have this GPS in my hand. It's like, do you realize where that signal comes from? Do you know that GPS is the timekeeping system, the banking standard? It comes from a satellite. I mean, everybody in this room knows it. You know, and everybody in this room probably knows what sequestration is. But you go to a church group, you know, your school group, sports team, and you ask them those questions, and hardly anyone knows what sequestration is, but we all do here. Not many people know what our systems do. Growing up, I watched Apollo, Gemini, I could name the astronauts. I applied, I was telling Larry earlier, I applied 3 times to be an astronaut. And you know, they're my heroes, I knew them all. I grew up in Philadelphia, and you know, I knew the astronauts before I knew some of the Philadelphia Eagles. How many people, you know, talking to kids today, they don't know any of the astronauts. You talk about shuttle, and you talk about, you know, Orion and Constellation. It's on, you know, the last shuttle launches were on the back page of the paper. They weren't, you know, really anywhere. We're great engineers. We're terrible marketeers. We just need to do as a community a better job of advertising what we do to get folks interested in it. Now, that being said, new millenniums, the ones that we hire, they are amazing. They are brilliant, especially in the IT world and information exchange. They collaborate naturally. They are able to multitask. You know, I have to do one thing at a time. My wife is always yelling. I got to do one thing at a time. These kids today are unbelievable. You can't give them enough work. I am so impressed with the talent that we have that comes out of the universities and schools today. I'm really proud to be handing over the reins to them. And it's one of the things I really like to do is mentor and train. I mean, what legacy am I ever going to leave? It's hopefully I touched some young person to be able to stay in this business, because it's the best business in the world.
Thank you, Mark. Roger.
That's great. Okay, so go back with me. In college, I took a class where you got graded by whether you knew how to select which pencil to use to draw which line on the drawing board. Okay, now I got an A in it, but I have described that course, which was a required course in the curriculum in engineering school at the time that I went. I have 3 kids, 2 of them are engineers. I have described that course to my kids, and the look of shock that they have on their face just has set me back. I've showed them the equipment that I used, and you know, they want to put it in a frame and make a decoration out of it. We have automated all of that for the millennials. By the way, a great resource of talent, but it is about changing the design of the jobs that we have in industry. And it's about partnering and collaborating with the universities and the colleges all the way back to elementary schools. These kids are coming IT ready, ready to learn, ready to contribute. One of the characteristics of the millennials is they will not wait around and do a 5-year drafting apprenticeship at the big design barn in Fort Worth, Texas, which is where I started. The first day on the job, they want to be designing the next satellite, the next rocket, the next human spaceflight vehicle. And what we have to do is change what we do in the industry to create jobs for which they will be excited and passionate to come and to work for us in the industry.
Great. Well, thank you, panel, first of all, for tremendous insights and tremendous information. And thank you, audience, for participating. And please feel free to continue on the conversation as we break. Thank you all very much.